Hey, my name is Nanocarp and I'm a quantum dot. My name came out when the Russian physicist Alexei Ekimov discovered me and my friends for the first time in a glass matrix while he was studying electronic and optical properties. Right now, you see me in a normal size, right? Quantum dots like me are nanocrystals. That means we're truly small and the normal world will look like a flat pill.
Hey Carp, I heard you're talking about us. Well, I also want to mention some information. Just to ensure people get to know us. You see, quantum dots like me and my friends are made of carbon, silicon, and some others are made of selenium and cadmium, and nanocrystals of gallium arsenide. And that one there is NanoSeal. Come here! Quantum dots are monochromatic and brilliant in any fluorochrome. That's possible because we are covered with zinc sulfur in order to increase fluorescence, and we are also covered with a shield soluble to water. We're brilliant, but truly brilliant. Once we're lighting, we can remain shining for hours or even for days, while our friends' fluorochromes only last for a few seconds or minutes.
You see, our colors are strongly related to our sizes. The smallest quantum dot, which is 2 nanometers big, is blue. Then comes green, orange, and lastly red, with 6 nanometers. Therefore, our sizes determine the wavelength emitted.
Our electrons in the inside are trapped and laid in a specific point without moving. Therefore, we are called artificial atoms. This precise arrangement gives us properties that can be controlled from the outside.
Now, our synthesis. Elements such as selenium, tellurium, and sulfur are used in solutions through hot pyrolysis. Pyrolysis is a chemical process that involves constant heat that allows organic decomposition where only metals and glass remain. In this type of synthesis, crystals are covered with polymers that make them resistant to degradation by enzymes or chemical agents. It doesn't sound that funny, but the truth is that the results are very helpful for later applications. We'll explain why.
We are useful in many things, but in which we are more recognized is by the lighting of multiple devices. Due to our emission and excitation with the inorganic LEDs, we can have a tumble emission, so we make colors that look more real in LCD screens.
We are also used in telecommunications, quantum computing, security, and biomedicine. Electronic optic is another application.
And in medicine, quantum dots identify cancerogenic cells isolated in blood vessels. They also release medicines and act as vehicles of genetic vectors. They are the future of medical diagnosis and oncological therapy. Quantum dots have several advantages such as substitution of expensive bulk and efficient materials, and we are produced by easy and cost-effective methods. We can observe photons of light for a long period of time. We require only a small amount of energy to be excited. We can be used in several forms like small crystals, in liquid solutions, as dust, and in bed form. All these forms not only make us look pretty and handsome, but also give us a huge range of applications in science.
Not everything's wonderful with us yet. We also have a few disadvantages, but scientists are working on our development to make us a lot more efficient. For example, most of us are composed by toxic substances, and sadly, due to our large size, it makes diffusion a lot more difficult through the cellular membranes, triggering the destruction of cells.
Another thing is that because of low absorbing and emitting energy makes transmitting undetectable, which provokes yield deterioration and makes us invisible.
And finally, engineers want to use us in fabrication of LEDs, but that hasn't been possible due to the manufacturing of the color blue, because it requires smaller sizes and a bigger emission than the other colors. It has to be bigger in order to make it detectable to human eye. Finally, scientists all over the world keep on working on the improvements that can be done in quantum dots to make them more efficient and with less disadvantages every time. Quantum dots are very important for technological industries due to their optical and electrical properties. It is a matter of time to make them part of everyday life. That's the purpose of our party. We celebrate our discovery. Bye!
Created using Powtoon.